Hello guys, welcome to this week's tutorial. I'll be doing the memorandums for the practicals. So I'm gonna start with practical 2. Yeah, because I feel like it's best if I do it that way. And then we'll gradually improve the previous solution to get to in order to get to the current solution or the current practical, which is prac 4. So we're gonna start with prac 2. So let's get straight into it. So the purpose of this practical, right, is just for you guys to become familiar with the basics of C++ classes. So the Industrial Internet of Things, IIoT, consists of interconnected devices, machines, and sensors to improve efficiency and productivity by enabling automation. So they're just basically talking about that, the industry of Internet of Things, which just comprises of interconnected devices to improve efficiency and productivity by enabling features like automation, basically automating things. IIoT is an extension on Internet of Things. Okay, so the industrial Internet of Things is just an extension of Internet of Things. That's what they're talking about there. To augment the capabilities of industrial sectors such as energy, manufacturing, transportation, aviation, water management, and smart cities. The theme for the practical assignments this year is analyzing the data collected by IIoT sensors and using it to make meaningful decisions. So we're going to analyze the data that's going to be collected by the industrial Internet of Things, the sensors themselves, and come up to a conclusion and use that conclusion as to provide something meaningful. So that conclusion is going to help us make meaningful decisions. So let's do that. So just going to zoom in a bit. Assume that IIoT sensor collects the following telemetry data from an industrial plant. So they're just telling you to assume that they're collecting this data from an industrial plant. So create a data structure to represent an IIoT sensor using an appropriate C++ construct for creating data structures that only have data without functionality. So without functionality, that's a keyword there. So let me highlight that. So without functionality, the IIoT sensor must maintain the following information, including the range of values, sensor ID, which is an integer that can be calculated by finding the current row index and the current column index by multiplying those two values. Then we have the temperature, which is a double, which ranges between 0 and 50. And then we have the humidity, which is an integer that ranges between 0 and 40, and etc. So before we get into that, let's talk about the differences between data structures. Okay, so um, let me do this. So let's talk about them. So I'm going to change this into C++. So there's a lot of data structures. There's arrays, there's record structures, there's vectors, there's a lot of data structures. So for now, we're talking about remember that this semester is just talking about OOP, object-oriented programming. So by object-oriented programming, by object-oriented programming, we're basically talking about that each each how can I put it? I can say each entity is going to be viewed, each entity is viewed as an object. So basically, we're gonna borrow from the concept of our real world that we live in. So for example, where you're seated right now, you're in a chair. A chair is an object. And each object has certain features, right? So for example, the chair, right? It is the functionality of you being able to sit on it. You can sit on the chair. That's one of these functionalities. And it has properties too. For example, the chair can be white, the chair can be blue, can be yellow, etc. So we're gonna borrow from that and try to simulate that in our code. So let's say, for example, I wanted to create a student. I wanted to create a data structure that represents a student. Let's say that's what I wanted to achieve, right? So what I can do is I can view the student and try to understand what type of features a student has. So a student can have two things. A student can have properties and functionalities. So for example, a student is a person, right? A student can run, a student can jump, a student can attend classes, a student can attend practical sessions, a student can get a can yeah, anything that you know that anything that you know a student can do. A student can read a book. Obviously, you couldn't be a student without that functionality. You should be at least be able to read a book, right? So that's just a section of the student, right? And then a student also has properties. Properties in the sense that we have things that can identify a student. So a student can have a student number, a student can have a name, a student can have an age, etc. So this is what you're gonna view as. I mean, you can sort of like combine both. Yeah, you can sort of say like the functionalities are also part of the properties of basically that those are the properties of a student. So, but I'm just gonna use the term property to represent such information. So by properties, what I'm going to say in simple terms, by properties, we mean that these are your what? Properties, these are just your what? Your nouns. And your nouns, they can be translated to what? Variables. So these are just your variables. And then functionalities, this can be translated to your verbs. Remember what a verb is? If you did, not if, all of you did English. So you should know what a verb is in simple terms. Just a doing word, right? So for example, run, swim, jump, eat, read. Yeah, I know it might sound mundane, me making such examples, but it's very crucial because that's how we're going to define our functionalities for that specific object, right? Remember that this whole concept is trying to simulate the real world. So that's those are your verbs, that's the functionalities. Or you can call them your functions. So this is this is how we're going to structure the object. It's going to have two things, the properties and the functionalities. And the functionality, property and the functionality, they go hand in hand, a variable and a function. So now with that being said, that's the reason why we needed classes. Because if you think about it, a record structure, right? Remember what a structure is. A structure is just me saying, okay, I have this structure. I'm representing a specific structure. I'm creating my own data type. So for example, if you remember when you create integer variables, right? So int min, let's say we wanted to find a minimum. So if I use this data type int, it doesn't provide, how do I put it? It doesn't group data for one specific thing. It's only representing one thing, just one value, one integer. So what if now I wanted to have a data type in such a way that I can represent something that is a collection of other things? By collection of other things, it's in essence, I'm basically referring to an object. So let's say I wanted to create a student data type, right? I could do this, right? That's the beauty with record structures. I can define my own data type. So here what you're doing is just doing what? Creating your own data type. That's all you're doing there. You're just defining your own data type. So inside this data type, you're going to put in properties that represent each student. Because remember that we're going to need to use this as a data type. So I'm going to need to create, let's say I wanted to create a student, right? I would have to do this. I would use the name of the structure itself, like this, and then I create a student. And then I give the variable a name. So what am I going to call the variable? So let's say student one is the first student. So this is very similar to what we had before. Creating an integer, it's also the same thing. As you can see, we start with the data type. This type is the type that I've defined on my own by creating what we call a record structure. It's a structure because it has things inside, it has things inside of it. So for example, building. A building has employees inside, it has chairs, it has equipment, it has all of those things inside of it. That's a structure. So yeah, they took from that concept that you can build your own structure, basically something that has things inside of it. So what are these things that are inside of it? It's just basically the information that represents each student. So what would we want? What would we love to store? We'd love to store their marks. For example, I'm going to make it a pointer. It's going to be dynamically allocated. By dynamically allocated, remember what that means. It means that I'm going to get the size from the user. The size is not known beforehand. So I didn't know the size while I was creating this application. So that's why I'm making it a pointer, because it's going to be dynamically allocated. I'm going to get the size from somewhere else. So I'm going to create that and call it marks. These are your marks, right? Your practical marks. Imagine that every week, right? Like, not imagine. I mean, every week you get a practical, right? So just know that behind the scenes, it's like this. You have the marks array, and then you have the practical number, things like that. So let's say this is the information that we wanted to store. That represents each student. It's the marks, and then we have their initials, and then we have, okay, their initials should be a string. Their initials, their student number, so you can have student number. And then as you can see, I've defined my own data type. I've created my own data type. The difference between my own data type and the predefined data types. By predefined, I'm just basically saying these data types come with the language itself. As you can see, it's highlighted in blue. That means it comes with C++. C++ gave me that data type. It defined it on my behalf. Because what basically happens is that when they create a language, they just look at the common things that are going to be needed in order to build systems. So for example, let's say I wanted to build a system about, imagine look at the world that we live in. It revolves around numbers. So for example, a bank account number, your ID number, your student number, everything revolves around numbers. Your marks, those are also numbers. Everything revolves around numbers. So they also added that functionality in the language. So you can have integers for representing whole numbers, or you can have doubles or floats for representing floating point values, or basically values with a remainder. You can also have that functionality. For example, you wanted to build a banking system. Obviously, it's not always going to be a whole number. So you'd have to use something like a double. So this is what comes pre-installed with C++. And we can extend what's pre-installed with C++ and define our own data types. Just like I did here, I created a record structure which which represents each student. So I've created a student structure. So I've created a student structure. So the key differences between my own defined type and the pre-installed or predefined type is that I can use it in a much different way. So remember that the way you'd use the normal type, right? Let's say int min. If you wanted to say to allocate a value, you'd say int min, right, is equals to 0, right? Simple, straightforward. But when it comes to my structure that I've created, my own data type, I would have to use the variable name that I've declared like that, and then I'll say dot. It's what I call in object-oriented programming, it's called a member accessor operator. So it's a member accessor. It means that it accesses members of a class. Remember, by what I was talking about, what I just finished saying about you defining your own data types. You're just creating something that has things within it. So it has things inside of it. So that's why in those things, in terms of classes, they call them members. So that's why it's called the member accessor operator. So even here you call that too. It's still fine because this this structure has what? Members. These are members. For example, family members, you can think of it in that way. There's family members, right? They're part of what? The family. So it's the same thing. These variables are part of this structure. So they are members. So it's called a member accessor operator. So this is called a member accessor operator, because it's meant to access members that are part of that structure or class, whatever you're dealing with. So you say dot and then you specify the thing that you want to access. Let's say I wanted to access the initials. I'd say initials dot initials, and then I'll say is equals to u else. Let's say those are my initials, right? So you'd assign it like that. So it's basically similar to how we've been doing it. If you check here, it's basically similar. The only thing that you're adding is this prefix. So you need to specify in which structure does this belong to by putting that prefix there. The variable name of that structure, and then you use the member access operator, and then you access that member, the specific member that you want to change values for. Or you can just display. It works this very same way. So let's say I wanted to display. You just say cout and then dot initials like that in line, which is exactly the same as we've been doing before. So it's like me saying it like this, but now I need to specify in which structure does it belong to. So this becomes flexible. So now I can have different structures representing each student. That's why when you go on Eve or you go to a platform, whatever, there's a sign-in page or login or register, whatever page that's there. For example, let's use the login. For example, when you log in, why does it remember you? Why is it only retrieving your specific information? It's because of concepts like this. Obviously, it doesn't use record structures. It's going to use classes because um, a student has two things. They're both properties and functionalities. So you'd rather use a class over a record structure, but it's the same thing. So that's why it's able to remember which student I'm referring to, because I use that variable name for that specific student. And then it only assigns or changes the value for that specific student. In this example, this is student 1. It only changes for that student 1, no other student. So yeah, you can even access all the other members the same way we've been doing it. But the record structure has limitations. The record structure, it was meant for only data, so only properties. So now it became a problem with just having a something that you can use to define your own data type, but you can also define the functionalities for that data type. So that's when they had to come up with things like classes. So with the class, it's basically the same thing as the record structure, but then with the class, it's just more functionalities. So We have the class there, and you can see they are exactly the same. They follow the same structure. The only difference is that this one is called struct, and then this one is now called a class. So with the class, just like with the record structure, you can have properties with the class. But then with a struct, by default, everything is public. So by default, everything is public. That was another problem with the record structure. But then with the class, it's good because by default everything is private. Then you'd have to create a specific approach to make the necessary information that you want public to be public, and then the specific information that you don't want to be public to be kept private. So you're only able to define properties for the record structure. And then with the class, now you can specify the level of access that each user has, and you specify what things should be kept public, what things should be kept private, what things should be kept protected, and what things should be kept as a friend access modifier. So these are what we call access modifiers. So these are access modifiers, which basically state the level of access that you have, which is good instead of making everything public by default. That's a problem. And now you can define functionalities. So you could say, for example, string to string. You can define a function like this. It supports that feature now. So basically, the only difference between this structure and this class is that this class has extra things. That's the only difference. So you could say that the class is like a struct 2.0, like an updated version of a record structure. It's the same thing. It's just that it has more functionalities, more capabilities than the structure. So you also create it the same way. So let's say I wanted to create um, a variable that represents a student. I'll create it the same way, the exact same way. I would say student and then student one, like that. And then when I want to access information, I would still use the member accessor operator and access the information that I want to access. Let's say I wanted to access this toString function. I'll just say toString, like this, exactly the same way. But then now I can access functions, I can access properties, I can access both, and I can determine the level of access that the user has on specific properties and functionalities, which is very convenient. So yeah, I think that should explain everything. So now let's just look at the practical. So okay, here's the practical. So let's create the specific files first. Okay, I think you only have an IIoT monitor, right? So I'm only going to create the header file for that. I'm creating a header file and a CPP file because of the concept called abstraction. Abstraction basically means that you keep the logical properties separate from its implementation. That's abstraction. Abstraction is keeping the logical properties separate from its implementation. And save that. So that's abstraction. So we're trying to do that so that it's easier for maintainers. It'll be easier for us to maintain the software instead of putting everything into one file. So that's cumbersome. It's just not a good approach. Because now let's say you have 16,000 lines of code. How are you going to maintain all of that? Then give it a name. Then I'm going to call it P2 Memo. And then click finish. And then I'm going to create the new header file. Remember that we only have one class. So with abstraction, for every class that you have, you must apply the concept of abstraction. So you must have both the header file and the source file instead of having one file to represent the class. So you must separate the information that you're writing. So I'm going to create a header file for this class, and I'm just going to remove that underscore included. Doesn't really matter. I just don't like it there. And then I'm going to create the source file. There we go. And then I'm going to say .cpp. And then I'm going to place it in my project folder. Okay, so now we have the files. So we have the files now. So let's see. So usually, okay, before we start with the class, we need to implement this. So we need to write this. So let's see. Let's just revise the record structure in the classes. The record structure is basically you defining your own data type, but with this data type, it only supports properties. So it's something that only has properties and no functionalities. And then with the class, it's something that has both functionalities and properties. So you can define variables and functions within a class. But inside of the record structure, you can only define variables, no functions. So since we revised that, let's go through it. So assume that an IIoT, an industrial Internet of Things sensor, it collects the following telemetry data from an industrial plant. So create a data structure, right? That's the first key point to represent an IIoT sensor. So what I would do is I'll just write IIoT sensor, because at this point in time, I'm not sure whether it's going to be a class or a record structure. So let's continue reading. Use an appropriate C++ construct for creating data structures. So use the appropriate one. They're telling you to choose. So use the one that only has data without functionality, which is a what? A record structure, just like we had previously discussed. So now I'm going to say struct because now I'm sure of what I'm supposed to be creating. They said I should use a data structure without functionalities. Data structure without functionalities. Right, so we know the right data structure and we've used the right data structure. So now let's see what should be inside of that data structure. So you're going to have a sensor ID. So what I'm going to do, I'm just going to copy this and paste it here so that I don't have to go back and forth. So I'm going to have a sensor ID, right? And they said it's going to be what? An integer. So I'm going to create an integer, and then I'm going to prefix it with int so that it helps me remember that this is an integer when I'm coding. So I'm going to call it int, and then int sensor, and then ID. And then this is going to be, I'm just going to add a comment here so that I can remember. It's going to be the row index times column index. Basically, they should have been more specific. It's the current index and the current column index. The current row index and the current column index. And then we have the temperature, which is a double, right? So I'm going to create a double, and then I'm going to prefix it with dbl so that I'll remember in my code that this is a what? A double. So dbl temp, I mean, you could write it in full. Let me just write it in full. dbl temperature. This is going to be in the range of 0 to 50. But since it's a double, I'm just going to say 0 to 50.0 and then starting at 0.0. And as you can see, they've already specified ranges like this. So when they specify ranges, just know you need to have an enforce range function, which enforces the range so that the user doesn't provide us with information that's going to be outside of our bounds, because this information is bounded. There's a lower bound and an upper bound. So we have that. So we have these two. We're done with those two. We're only left with these three. So I'm going to have a humidity. They said it's what's an integer, right? So I'm going to create an integer, then int humidity like that. It's going to be in what range? 0 to 40. So 0 to 40. And it's an integer, so I'm not going to say 0.0 to 40.0. It's an integer. So next is the pressure. So that's a double. So I'm going to say double. And then I'm going to say dBl, right? dBl what? Pressure. Like that. And then it's going to be within what range? The same range, 0 to 40. But this is a double, so I'm going to say 0.0 to 40.0. And then I'm going to have the last thing, which is a light intensity, which is also a double. As you can see, they said it's a what? It's a double. So double, and then prefix dBl, and then intensity. And then it's going to range between 0, it's a double, so 0.0 to 200,000. So 3 zeros dot 0. So now I'm done making my data structure. So that's how the data structure looks. So now since I've made my data structure, let's continue reading the practical information. So we're done with this first bullet. This bullet point, we're done with it. We've made the data structure and we've used the appropriate data structure, the one that provides only properties and no functionality. So there's no functions. I only have variables. And then now you should create a class. They even told you straightforward. They didn't say a data structure that has both capabilities, which is basically having properties and functionalities. So let's create the class. So it's an IIoT monitor. That's what it's called. So I'm gonna come here immediately after creating the record structure, and I'm gonna call it class IIoT monitor. Exactly the same way I've named my what? My header file and my source file. They need to match with the class. So I've created, okay, let me just close this. So I've created the class. It says that it manages a two-dimensional array of IIoT sensors. So that means it's a two-dimensional array and it's dynamic. Remember what I said about dynamic? It's going to be, the size is going to be provided by the user. So I'm going to get it elsewhere. While I was making this program, I didn't know the size. So that means it's going to be dynamically allocated because the size is not known beforehand. So before we continue, okay, two-dimensional array, okay, of IIoT sensors, right? So we'll get to that. So let's start with this, the rows and the columns of the area covered, right? So by default, the way you'd create your class, right? The way you define your class should have private. Okay, I'm gonna start with public, and then I'm gonna have private. There we go. So I'm gonna have private and public. So by default, everything in a class, that's a variable. most of the time we're just gonna look at variables. So for example, these are your rows, this is your array, that's a property, right? So everything that's a variable, it's going to be private by default. Then as time goes on, when you realize that, okay, the user needs to have access to this, we're going to create what we call accessors. And then if you realize that this data is mutable, so I'm going to create mutators. Mutable means that it can be changed. So I'm going to create mutators for that as we go on. But for now, by default, everything should be private. Everything that's a property. So I'm going to have int rows, and then I'm going to have int calls for representing my number of rows. And then this represents my number of columns, right? So we have that. So by default, everything that's a property, we're going to make it private. So we've made the rows and the columns private, right? That's done. Now we need to make the two-dimensional dynamic array of what? Sensors. If you're not sure what sensors are, they told you at the top there. They said which manages a dynamic two-dimensional array of IIoT sensors. So that means, remember that when we talked about a record structure, you're defining your own type. So basically what they're saying is that use that type that you've defined as the type of this class of that array that we're going to use. It's going to be a two-dimensional array, right? So it's like, for example, since you're used to having like a two-dimensional array of integers like this, right? Or even a two-dimensional array of doubles like that, right? So instead of doing that, they're telling you to use your own predefined type, which is the type called IIoT sensor, like this. So we're going to use that type that we've created, that we've defined. So that's it. And two-dimensional, remember that every pointer represents a dimension. If I have one pointer like that, it's a one-dimensional array. So since the practical requires me to create a two-dimensional array, I'm going to put 2 pointers there. So 2 pointers, that means two-dimensional or 2 dimensions of sensors, IoT sensors, right? So I'm going to call them sensors like this. Done. But let me see. Let's let's use the underscores so that you can become familiar with the underscores. So with the underscores, okay, we'll get to that. Let me leave it like that. I'm just gonna leave it like that. So we have a two-dimensional array of sensors covering the area that is monitored. We did this. That's what we just finished writing right now. The two-dimensional array of IIoT sensors. So we're gonna have, they said you should create now we creating constructors. So constructors, remember what a constructor is. It's basically taken from the term construction. So it's needed in order to build the object, right? So what happens is that when you use a class, this is what happens. So I'm gonna use draw.io to demonstrate. Let's wait for it to load. So I'm gonna give it a name. I'm gonna call it Tune. I just wanna show you this diagram. So what happens is that when you're working with classes, you you that means you're working with objects, things that we call object. And that object is basically an instance of the class. So with the class, the reason why we call them instances and stuff, because the class in this scenario, it always acts as a template or a blueprint or some plan. So you can imagine, for example, you wanted to build a house. And in order to build a house, you need to have a plan first, right? So you can imagine the plan as being the class itself. That's the class. And its implementations, how everything's going to be implemented, how many fitted in equipment the house is going to have, what's the color of the house, all of that information is going to be added into the blueprint or the plan for the house, right? And then once we've made the plan, what's the first thing? What's the next thing what's the next thing that we're going to do? We're going to build the house. So basically, going to put the plan into action. So that's what it means when you're making an instance of a class. You're basically putting the plan into action. You're actually building that object, which is a house. In this specific example that I'm making, you'll be building an actual house. So it's the same thing. So in order for you to build a house, right, you need builders. You need builders, right? So it's the same concept here. You're gonna need constructors in order to construct. Construct is just basically a synonym of build. So you're gonna need constructors in order to construct the object. And the object is basically a manifestation of the blueprint of the plan. You're basically putting the plan into action. So when I have this is going to be the object. So for example, imagine this is your house. Now you've built the house. There it is. So in order for the house to be built or the object to exist, you're gonna need constructors, you're gonna need builders. So that's why we define constructors. That's why we define builders, because they're gonna build the object itself. So what happens is that when you instantiate an object, so when you instantiate a class, I mean, basically when you create an object, you are basically saying you should allocate memory and build the thing. You should invoke the constructor or the builder to build. And then depending on the builders that you've called to build the object, is going to build that specific object. So this is what happens. It builds that object like this. And then the object exists in what? In memory. In memory basically means it exists in that world. For example, before you built the house, it wasn't in existence, right? But then after building the house now exists on what? In that street, in that on planet Earth, whatever you want to put it, it now exists. So that's the whole purpose of a constructor. And the reason why we have different constructors, you can view them as like, for example, sometimes the user or the client might require the house to be structured in a specific way. So for example, they want a default color. They want a specific color. It should be it should be violet, something like that. It should have a fitted in wardrobe, fitted in furniture and things like that. Right? And the swimming pool, those are the details that the user can provide when building the house, right? So that's why we give the user variety of options for them to build the house. You can have this constructor, the default constructor, whereby the user doesn't give you the information. They don't tell you, okay, I want a house that's going to be like this. I want a house that's going to be located in a specific area. They don't provide you those details. So all they want is just a house. They just want a place to stay in. So that's why we provide them with all these options. There's a default constructor. By default, it means that they don't provide you with any information. They just want the house. Then there's the parameterized constructor. It means that it has parameters. It's parameterized. So it comes in with the values that we get from the user. So this is just the specifics, the information. How do they want the house to be structured? How big do they want the house to be? How wide? What colors? Should it have fitted in? Should it have a swimming pool? Should it have a basketball court? And things like that. That's what that's why we provide different constructors or different options for them to take. So let's define those different options, right? So let's start by creating a default constructor. So let's do that. So by default, it means that it's parameterless, comes with no parameters, because we don't require any information from the user, right? They just want a house. We just gonna come up with what we think a nice house would look. So that's why this one is called the default construct. By default, you find it like that. You find the house like that. You don't specify, you don't really care about the specifics. You just want a house. And then now the second one is where the user is going to provide us with the information. So what information are they going to provide for us? Now we create a parameterized constructor. So this parameterized constructor, they say it should take in the dimensions of the area being monitored. And the dimensions, they discuss them in this first bullet. They said it's the number of rows, which is the height, slash, forward slash columns, which is the width of the area covered. And then that's basically what they mean. They mean the rows and the columns. So let's pass the rows and the columns. So I'm gonna have end. Okay, so you don't really have to do this and say, for example, in rows, comma. You don't have to create the variable here because you're not gonna write implementation, right? This is just a header file. So you can create what we call a function signature or a constructor signature. So it's a signature. It's basically you specifying what's the structure of data type that you're gonna take in. So I'm gonna take in first an int, and then the second one is going to be an integer. Why? Because my rows and columns are of type what? Integer. And then we're gonna take in the other information, which is we're also gonna get default values for all the sensors. So we're gonna get the default values for all the sensors. So you can do it in many ways. You can pass all of the types as they are. So by types, I mean you can pass the integer, the double, and an int again, and then a double again, and then lastly you pass the double. You can do it like that. But we remember that we've already defined our own type. It's an IIoT sensor. So I'm just going to pass in an IIoT sensor there. And then, yeah, I'm just going to leave it like this. I won't say, for example, sensor, because I'm not going to use it. I'm not going to implement in this class. I'm just going to create a signature and tell it, okay, I'm going to pass in an integer first and then an integer secondly. And then the third type is going to be a type of this structure. So that's fine. I should just leave it like that. That's fine. Now we need to create what is called a copy constructor. So the copy constructor is basically, as the name signifies, it's meant for copying. So it's basically you wanting to make a copy. So for example, it's like you move into, or you just let me not say move into an area. Let's just say you're scrolling on the internet and you see a beautiful house. So then you decide, okay, I'm just gonna make a copy of that house. I'm gonna make the exact same house. So now you're gonna provide information to the builders to build you an exact replica of that house. So you're just gonna make a copy of that house. So that's basically what the copy constructor does. It just makes a copy. So I'm gonna do that. So I'm gonna create the copy constructor. Remember, it's a constructor. It must have the same name as the name of the class. Why am I having it the same name as the name of the class? Because remember, that's the thing that you're building, right? So obvious, it must have the same name as the class. You can't say, okay, I'm gonna build a toilet, for example, but then you call builders that specialize in tiles and building tiles. That's not that's not what they can build. They can build tiles, not what you specifically require at that moment. You require them to build your toilet, right? But then you call builders who specialize in building tile or or fitting in tiles. You see, it becomes it becomes a contradiction now. So that's why it's going to be named the exact same name as the name of the class, because that's what you're building, right? And remember what I said, the constructor is basically another term for builder. These are different types of builders. So this one is not going to be necessarily building, it's just going to be, yeah, it's going to be building, but it's going to build a copy. That's why you're going to call it a copy constructor. It's meant for copying, it's the copycat. It's like that one person who's always copying you. For example, today you rocked Air Force Ones, and then they copy you. They're like, no, I also want Air Force Ones because he or she has Air Force Ones. They're just copying what you have. They like your style, something like that. So this is going to be a copycat. So let's see the extra information. I'm not done yet building the copy constructor. So sorry about that. So we are building a copy constructor, right? So I need to pass in what I'm going to copy. What am I copying? Remember that I'm just copying myself. That's all I'm doing here. I'm copying myself. So I'm going to pass myself as the parameter. That's what I'm going to take in. I'm going to take in an object of this class. It makes sense, right? You can't be making a copy of a paper and then get a copy of a car. Doesn't make any sense. If you're copying a car, you get back a car. If you're copying a piece of paper, you get back the same information that was there on that paper. But remember that I'm just copying the data, so I shouldn't change it. So how do I tell the compiler that, okay, don't change this data? I'm going to put in a prefix of the keyword const. Constant means that it's going to be constant. It cannot be changed, just like pi, the value of pi. It's just a constant value. You can't change it. The speed of light, things like that. It's a constant value. It can't be changed. So I'm going to put the prefix const there. But then if I leave it like this, the problem is that I'm going to get the object itself. And I don't want that because that's going to make my program slow. If I take in the object itself, so for example, the object, it's a size of, for example, 1 gigabyte. That's how big the object is, right? Since we're dealing with computers, I'm going to use gigabytes. So imagine that's how big the object is. And I'm taking that whole 1 gigabyte file and making a copy of it. That's going to take a lot of time. That's a very big file. So I end up having memory issues. So the best thing to do is to pass it by reference. So it's for me to put an ampersand there. That means I'm passing it by reference. By reference, it means by address. So instead of me getting the object itself, what I'm going to do, I'm going to get its address, its location. Where is it located? And then I'll rather go there to where it's located and then do whatever I do, make the copy and then come back. Instead of just taking in that whole object, that's very big. So now instead of taking, let's say, 20 gigs of space, I'm just gonna go to take an address. The address can be some kilobytes, very small. Then I'd use that address to go where it's located. I make a copy of that object and then I give back the copy to the user. So now it makes my program very fast. So I'm gonna leave it like that. And then I'm gonna create a destructor. So remember that we have a constructor, right? The builder. So since we have the builder, we also need to have the demolition team, right? The team that's meant to demolish or destroy the object when it's no longer in use. It's like, for example, when you don't need the house anymore. You just left the house, it's now deserted, it's no longer in use, right? The best thing to do is just to destroy it, right? Because it's no longer being used. And then people who want to use that land or whatever, they're gonna use that land and build their own houses, right? Because that one is no longer in use. So it needs to be destroyed. So that's how it operates. It has a life cycle. An object has a life cycle. There's this creation part where you create through the constructors or the builders. Then you have the demolition team that demolishes the object when it's no longer in use. So that's the word destructor. As you can see, it's like the opposite of constructor. So destructor comes from the keyword, from the word destruction. So it destroys that object when it's no longer in use. So we need to create that constructor there. And then we're going to create a set sensor data function. So let's do that. So this function, okay, set sensor data function, right? So before I decide where to place it, whether I'm gonna make it private or public, I need to decide. So the constructors are always gonna be public because obviously you need to build that thing in order for the user to see it, right? You can't build something and they cannot see it. You can't build them a house and they're gonna see the house. That's just you being a fraudulent person. You don't want to do that. You want the user to see the end result, right? So you're gonna make it public. So we have a set sensor data function that generates random sensor data. So this generates random data for each IIoT sensor using the range of valid values. So this function, so this is the keyword, this is the key sentence. This function must be called inside the constructor. The fact that it needs to be called inside something that's public, that can only mean one thing. It's going to be private. So as you can see, they didn't talk about returning anything that it's supposed to return. They just said it generates. So I'm going to make it a void. You don't return anything. It just generates the random values. So it needs to be private because it's going to be called inside the constructor, which is public, by the way. So there wouldn't be any reason for me to make it public and then call it again inside something that's public. It doesn't make any sense. That means it has to be, it has to have some sort of restriction. So I'm going to make it private like this. Then, yeah, that's all you need to do. So for now, and they didn't say it should take in something as a parameter. They didn't talk about that. They just said it generates random sensor data. That's all they said. And then the next thing you're going to have is a toString function that returns. You see, now they're being specific. They're telling you that it should return something. It returns a string using a string stream. So let's do that. So now this one, they didn't talk about it being called instead of another function that's public or anything like that. So we're just going to assume that's going to be public. So yeah, we're going to make it public. And they said it should return a string. So string to string like this, done. So now we're gonna go back and check. It returns a string, right? Representing the states, the sensor states. So it's gonna represent, those strings are gonna represent the state of the sensors. So with that being said, it's gonna return, right? So that means it's not really doing anything. They didn't talk about it, didn't tell you about changing values and things like that. So since you're not changing values or doing anything of that nature, at the end of the function, you need to use the keyword const to specify that this function is not meant to change the data. It's meant to just view the data. As you can see, we're just viewing the data. It says a more functioning or faulty sensor is defined as follows. You see, you just view the data if a sensor has the specific value, right? They say if the sensor has this value, do this. If it has this value, do this. Output this. They say output. They didn't say change. If they said change, then I would have left it without the const. But here they didn't say change, so I'm gonna use const because I'm not required to change anything. So let's let's create the constants. So we are done defining the class. Let's create the constants, because remember that what they said here, they said this is going to use the default constructor is going to use default values or default class constants. So I'm going to need to create the class constants. By default, it means that I'm going to mimic this one, the main constructor, right? But I'm going to provide default values. So I need to create default values of these types. So I'm going to create the first one, which is int, right? And it's default values. So since it's default values, I'm going to need to, they're never going to change, right? These values are never going to change. So since they're never going to change, I'm going to start with the keyword const to tell the computer that, listen, these are constants. They're not going to change. And it even says so here. They said class constants. So you must make use of constants. So const int, and then what's the first int that I was taking in here? It was the rows. So it's basically this information here of these types basically. So I'm gonna have default, you call it default so that I know that this is default. And then I'm gonna say it's 25 by 25. And then I'm gonna create another integer, because remember I have 3 values that I need to take in. So I need to create 3 constants. So const int and then default underscore calls is equals to 25. And then const, what's the other one? IoT sensor. And then default underscore sensor. So we have that. Now the question is, I'm going to say it's equals to what? Remember, this is my own defined type. So there's 2 things that I'm going to vary from. There's 2 things that's going to make this particular constant vary from this one. So what are those 2 things? For example, here I'm going to make this a const expression, because how I'm going to initialize this, and if you look how I'm going to initialize the variable depends on its data type. Remember, this was just an int, so it takes in 1 value. This is my own type that I've defined, which has 5 values. So I would rather use the keyword const expression to specify this is an expression. That means there's more. I can just basically say there's more than 1 value. Yeah, I can put it in that way, in simple terms, more than 1 value. And we can just confirm by going here in the textbook and then searching const question. Okay, it's taking time. Okay, let me just check the page number. I don't know, why is it taking so much time? Let me see, namespace, that's not it. If else, switch statements, nope. Type def, nope. I don't see it here. Let me just give me a minute. Let me check. Let me look for it. Okay, let me check this side. Okay, chapter 2, basic elements. Okay, let me click here on reserved keywords. It's not showing. It's only showing the data types for now. Scroll down. Let's see if we can find it. Why is it saying no match is found though? Hmm. Do, where's this const expression? I saw it. And okay. It's not showing, but yeah, the const expression just basically means that there's more than one value. So for example, you can a double can also be a const expression. Why? Because remember that it's 0.0. So there's like more than one thing. So there's more than one, you can just say more than one character, something like that. So we have the 0, that's 1, then 2, that's the dot, it's already more than 1, and then 3, you see. So you'd rather use a const expression. So the same thing applies to IoT sensor because there's more than one value. If you check, there's a struct, it's a record structure, so there's more than one value. So the way I can initialize it, I can use this curly braces like this, and then specify the default values in the exact same order like this, starting with an integer, followed by a double, followed by an integer, followed by a double, followed by a double. So let's do that. So I'm just gonna give it any default values that you're thinking of. Any value is perfectly fine. It's perfectly reasonable. So let's check. So with the sensor ID, I'm just gonna say 0. Yeah, because it's just a row and the column times the row times the column is just a 0, and that's an integer. And then the second one is the temperature, which is a double. I can just say maybe 24.5, just literally any value that you feel like writing there. And then an integer, the humidity, I'm just gonna say 40, and then comma, the pressure is a double, I'm just gonna say 37.8. And then the light intensity is a double from 0 to 200,000. So I'm just going to say 156,000. That's 0. Remember, it's a double. And then that's it. You're done. Let me build. It should complain. Okay, it's not. But it should. Okay, it doesn't really matter. It won't complain. Yeah. So now there's something that's missing now. It's the keyword static. So remember that this is going to be the same for all the objects. So what's going to happen is that every object that you build, remember it's not a house object anymore. It's a IoT monitor object object like this. So every time you instantiate or create an instance of this class, it's going to make an object in memory like this. And then that object is going to have the specific values, which is everything that's here, the constructor, the constants, the default rows, default columns, the toString function, the void set sensor data, the int rows, the two-dimensional array. It's going to have everything. That's why you do UML, because that's exactly how it's going to look in memory. So you're going to have that object, and then you're going to have the default rows like this. Then let me increase the size. Copy, paste, paste. I can have default rows and then a default sensor. default calls, and then default sensor. You're gonna have all of those things, all of that information, right? So what happens is that when you just leave them as constants like this, and remember that they're not gonna change for all the objects. So when you leave them like that, let's say I wanted to create another object. I create another object, there's another object, right? This is a second object. This is going to be IoT monitor object 2. It's the second object. So imagine we have that object. So when you just leave it as const, what happens is that it creates the exact same replica and adds the exact same values for this object. So it just makes a copy. In a way, it makes a copy. It has the exact same values. So you see, this object has the very same values, but it has its own copy, it has its own values. And then this one has the same values, but it has its own copy. And that becomes a problem now because we are redefining the same thing over and over and over for every single object. So now we need to use the keyword static. By static, it means that it it's more like it belongs to the class, not to the object. So in the sense that they're going to share this these constants, they're going to share instead of them having each individual having his or her own copy. So what's going to happen is that it's going to do this. You're going to have this object here. Okay, let me put it down like this. You're going to have each object is going to share. So now I'm going to copy this. Uh, okay, it doesn't want me to copy. Let me do this. I'm just gonna drag and drop like this. And then this is gonna be default rows. And then copy paste. Gonna have default columns. So I'm gonna go there and change this to calls. Yeah, and then also it's also gonna have the default sensor like this. Then I'm gonna click here, pick like that. Then I'm gonna zoom in into enlarge this other values like this. So by making static, it means that now they're going to share. They're going to reuse the same thing. So you can imagine it's like you and your friend, you like the same hoodie or whatever, and then instead of buying two, so each person has their own hoodie, you bought one that you're going to share. So it's the same concept here. When you use the keyword static, they're going to share. So it's just going to be sitting there. And then whenever this one wants to use it, you can just go there and take the values that he or she wants to use. And then when this one also wants to use, it's going to go there and take the values that they want to use at a specific moment. So they are sharing instead of them having their own copy, which is going to save us a lot of memory. Let's say I have 56,000 objects. That yeah, it becomes, I mean, for now, when you see it, it's just two objects. Like, okay, it's not too bad. I only have two objects in memory. But when the objects become more and more, you realize, okay, I'm gonna have memory issues. So that's why you need to use the keyword static so that it becomes shared instead of each object having its own copy. So I'm gonna use the keyword static there. That means they're going to share these exact same values. So yeah, we have our constants now. So since we have our constants, yeah, I think now we're done creating the class. Now we can write its implementation, right? So I'm going to copy everything to there. Before I start, I need to say hash include IIoT monitor like this. So when you use the hash include, what happens is that it copies and pastes everything inside of this file into your CPP file, so that when you're coding, and then you say IIoT sensor, it knows what you're talking about. It's like, okay, I know that. I know what you're talking about. I know what you mean. And then when you say IIoT monitor, it's like, okay, I know that that's a class. So it's going to copy everything that you've written here, all of the code that's in here. It's going to copy and paste it inside here because of this command hash include. So in a way, you can view it like that. It's like it's just copies and pastes that code inside of your implementation file. So now I'm going to implement my constructors and my destructor and the functionality of the application. Okay, I forgot to, yeah, it's going to complain at some point. So remember that this belongs to the standard namespace. So I need to specify where does it belong to. It belongs to the standard namespace. So yeah, that's gonna fix that issue. And then I also need to add my imports here. I'm gonna say hash include uh, string class because I'm using a string. And then I'm gonna use the string class to implement the toString function, remember? And then I'm gonna include the IO stream because I'm gonna use things like cout and so forth. And then I'm gonna have the ctime library because I'm gonna generate random values. And then I'm gonna have the C standard C standard library because I'm gonna use the exit function. Which will I use the exit function? Yeah, I think I will. Yeah, I will create the enum for that. Oh, and remember that we have ranges, right? We have ranges. So I need to create an enforce range function. And it's gonna be private because it's not something that I want the user to know about. It's just gonna be a helper function. Helper, it means it's just gonna help me write less code. Instead of rewriting the code over and over and over, I'm just gonna write it once and then call this function. So it's gonna take in the value that I'm going to be checking, which is an int value. And then I'm gonna call it, okay, remember that you can just use signatures here. I'm just gonna use signatures. So it's gonna take an integer that I'm checking, and then it's gonna take in a lower bound, which is the starting point, and an upper bound, which is the stopping point. And then I'm gonna copy this, add it into my CPP file. And then I'm gonna remove private, and I'm gonna remove these lines of code. Then there we go. So I'm gonna create this IoT. In order for me to implement every single function and the constructors and everything, I need to specify in which class are they coming from. So I need to use the scope resolution operator. By scope resolution operator, it just means these two colons like this. That's the scope resolution operator. So I'm gonna say, the first thing I write is the name of the class that it belongs to. And then I use the scope resolution operator to access it from the class. And then I implement it. And remember, I did say hash include at the top. So it's going to know what is IIoT monitor. Is it a type? Is it a what? It's going to know what it is. So I'm going to repeat the same process for all of my member functions. and then do this. And I'm going to put it there next to the function name. Remember that this is highlighted for a reason. I didn't define it inside of my class. I didn't create something called void here or a function called void. I didn't do that here. It came pre-installed. The thing that I defined on my own is the function. So I'm going to say scope. I'm going to use the scope resolution operator next to the function name. And then I'm going to do the same thing for the other ones. Remember, the string is not defined by me. It came pre-installed. I can put it in front of the string. And then the destructor. And then I put it in front of the function name because that's what I defined. And then before we continue, let me import it to my main so that I can check if I have any errors. So include the IoT monitor.h. Let's see if I have any errors. Okay, there we go. Yeah, it belongs to the standard namespace, right? So since I'm going to be using the standard namespace a lot, or tools that are within the standard namespace, I'm going to say using namespace standard, like this. And then I'm done. So now let's implement our constructor. So the way I'm going to implement it, remember that these two constructors are going to have the exact same implementation. So we're going to use the concept called constructor chaining. So constructor chaining, it just means that copy and paste another constructor's implementation and use it as my own. But I'm going to pass in different values for those specific values that that constructor used. And remember that I'm inside of my class, of my implementation file now. So I need to give the parameters names because I'm going to use them. I'm going to need to access the values that are being passed. So this one I'm going to call it int rows. And then this one I'm going to call it int calls because it represents the columns, space int calls. And then this one is just going to be called sensor. And then this one's going to be called obj monitor because I am literally getting an object from the user. And then this one I'm going to call it int value. Then this one I'm going to call it int min or int lower. And then this one I'm going to call it int max, or you can call it int up. And then yeah, that's pretty much it. So now let's implement. So I'm gonna have this constructor, right? Let's implement the constructor first. So before we start, I need to take the values that I got from the user and store them inside of my member properties, my member variables. Remember, that's the whole point of me getting this so that I can know how to build the house. Remember, this is a constructor. It's meant for building. It's meant for construction. So here I'm taking the information from the user about how they want this object to be built, how big they want it to be, which is the width and the height and the width, and the sensors, the default values that they want for them. That's how I'm going to do it. So let's do that. So I'm gonna say int rows in my class is equals to that int rows that I'm getting from the user. As you can see, now we end up running into a problem because now this is it's named exactly the same way. You won't be able to tell the difference between this intros and the intros that's inside of my class and the intros that I'm getting from the user. So that's why most of the time they use this approach. They can name it differently and say underscore rows so that you know that this is the rows inside of your class. And then you name it however you want to name it, your parameters. But there's also a very cool feature. You can use this operator. This operator means that this current instance or this current object set its rows in set a specific member variable or member function to something, right? So the way you do that, you put an error like this. This basically means the same thing as you dereference to get the object itself. And then after getting the object itself, you say dot, and then you get the rows. But this got simplified. I think it was C++ 17. So it got simplified to this. So now you can write it like this, and then arrow makes things simple. And then I'm going to do the same thing for my columns. As it goes to int calls like this. So I'm just setting these ones. That's why I'm using it. That's why it knows the difference it will know the difference after I've used this, because the moment I immediately use this operator. So for example, I say this, and then I'm going to choose, which one am I going to choose? The census, right? And then, okay, no, not that. We're not going to do that yet. But before I set the rows and the columns, I need to enforce the range. And before I enforce the range, I need to create constants for that, which is your default, your maximum, I think it's going to be max row and minimum row. So I'm going to create constants for that. Remember, I'm going to use 30 const because I want them to all be the same. So mean, I'm going to call it mean underscore row, mean size. Let's use size, because I'm going to use it for both rows and columns. So I'm just going to use one value. So let's say the minimum, the minimum should be at least 0. And then the maximum should be some size. It can be 100,000 or million, whatever, but just use 100,000. It's just some size. It can be any value. But just make sure it doesn't exceed the capacity of an integer. Remember that an integer has a specific maximum capacity. So before we do that, remember that we need to enforce the range. So before I can enforce the range, I need to implement the function for enforce range. So let me do that. So I'm going to say, it's very simple. I'm going to say if the current value is less than what? The second parameter, which is going to be the minimum. If it's less than the minimum that we want, then what should happen? Use the cr to output an error. So output an error. What is the error? The error is that int value is less than what int min. It's less than the minimum. And then you put a new line character. Or you can just say less than the minimum. And then you specify what minimum value so that the user knows what the minimum should be. So I'm going to copy this and repeat the same thing for the maximum. But I'm just going to change the symbol and say if it is greater than the maximum, that means it has exceeded our upper bound. So I'm just going to say maximum, change this one to maximum, and then say is greater than the maximum. What's the maximum? It's int max, which is the third parameter that we're going to take in this function. As you can see, it's going to be the third parameter. So after this, we'd typically want to exit our program because there's not much a user can do if they give us the wrong dimensions. So I'm going to use the exit function inside the C standard library. It expects an integer for me to exit, right? So I'm going to create an enum for that with my constants. So enum status, I'm going to call it status like this. And then it's going to have starting at error min. Then I'm going to have error max. And then I'm going to have success. So remember that an enum starts counting from 0, right? It even shows you, check, if you hover over it, it shows you what each value is. You see, it starts from 0. Let's check error min. Let's check come on. Let's check error min's value. You see, it's equals to 0. It starts from 0, and then it starts incrementing by 1 or increasing by 1. What is error max? Error max is 1. So remember what success means. It's a value of 0. How do we know? Because in the main function, this 0, it means successful. So I want it to stop at 0 here. That means I need to count from negative. So I'm going to start from, let's say I want to start from -1. Let's see if this will be 0. So -1, and then in the next line it's going to say -1 plus 1 is just 0. And then the next line just going to say the previous value, which was 0, plus 1, which means going to become 1. So yeah, -1 is not a good starting point. Let's say -2. Let's see what happens. So -2. So what happens, it takes the previous value and then adds 1. So the previous value is 2. And then I add a 1. What do I get? -1. And then the previous value before success, it's -1 plus 1. What do I get? It's a 0. So yeah, -2 is perfect. That's fine. So you can combine and just say error range. But yeah, I'm just going to use error mean and error max so that we know which one is the max, which one is for the maximum and which one is for the minimum error. So I'm going to pass error mean there, and then I'm going to say exit, and then I'm going to pass error max. And then I'm done with my enforce range function. Now I'm going to use it. So before this line, before allocating, remember the computer starts from top to bottom. So I need to enforce the range before I store the value. So enforce range for what? Enforce the rows. And then it starts from what size? Min underscore size to up to what? Max underscore size. And then I enforce it's the exact same range that I'm going to enforce for my columns too. So I just copy and paste. So copy, and then I'm going to put int calls there. And then remember we have the what? The sensor. So I need to enforce the range for the sensor. Every single value in the sensor, I need to enforce the range. So let's do that. So you could, you could, hypothetically speaking, create your own constants for each sensor. You could, okay, not each sensor. Okay, yeah, sensors are different. Yeah, sensors are different. Let's see. Okay, sensor. So I'm gonna use this sensor and then check each value. So sensor, and then I say dot. And okay, why isn't it working? Okay, sensor dot. Wait, so what if I did the sensor dot and sensor ID? Let me check something here. Error max. Oh, I forgot to put a semicolon there. Build. Okay, it isn't complaining. Okay, let me do this. That means it's just not highlighting that it knows what I'm talking about. It knows about sensor ID. Let's see. Yeah, there shouldn't be any issue, but I don't know why it's not highlighting though. So that IoT sensor that I'm taking in, I'm going to check the sensor ID. The sensor ID needs to be in what range? So with the sensor ID, we don't have to worry about the ID. Remember that ID depends on the row and the columns, and we've enforced the range for the rows and columns. So there's no need for us to be redundant. So now I'm going to enforce the other ones that come after the sensor. So let's start with DBL temperature. DBL temperature starts from 0.0 to 50.0. So let's just create constants for this. So I'm gonna have static const double. Okay, remember this is a double now, so it's gonna have more than one value, so I need to use const expression. So min temp equals to 0.0, then static const expression double max temp. Maximum temperature is 50.0, and then we're gonna have constants for the humidity, which is an integer. One copy. Okay, for the humidity, so I'm gonna say min hum, and then max underscore hum for humidity. So the maximum is 40, right? Yeah, it's 40. And then temperature, this is going to be an expression because the temperature is a double, and double mean, no, not temperature, the pressure. Mean press, I'm just gonna call it press. It's a double 0.0. Then max press. Let's go max press. It's going to be 40.0, and then this is a double. Then it's a const expression. Then we're gonna have intensity, which is also a double. Intensity. I'm just gonna call it mean light. So it's from 0.0 expression double, and then expression again because it's a double. And then I'm gonna have max light. So max underscore light going to be equal to 200,000.0. So we have all the constants that we need. Yeah, we have all the constants that we need. So let's enforce the range. So this is min temp, min underscore temp, and then max underscore temp. Let's just double check. Yeah, we've enforced, that's fine. Then I'm gonna do the same thing here. I'm just gonna copy. I'm gonna do this 4 times. So I'm just gonna copy, paste this 4 times. And then I'm gonna change the variables. So the humidity comes after. Humidity comes after. So we're gonna be min hum, then max hum. And then I'm gonna go here, dBl pressure, and then it's gonna be min press, and then max press. And the last one is the intensity. It's gonna be min light and max light. Min light, then max light. So that's it. Yeah, we've enforced the range. That should be fine. Okay, yeah, the only thing we just have a warning because the toString function is not returning anything, but we'll get back to that. So here I'm enforcing the range to make sure that the values are in range. That's all you're doing here. And then this line of code, we're just getting the rows and columns from the user and storing them. And then now we need to start allocating the array. To remember that we're managing a two-dimensional array called sensors. So I'm going to say sensors is equals to new what? IIoT sensor. And then pointer like this. Remember that each pointer represents a dimension. So I'm going to allocate the size of that dimension by starting with the outermost pointer. So to allocate the size for the pointer, you replace the actual pointer that you're allocating the size for with square brackets. Then you specify the size within the brackets. Then I'm just going to say this is int rows. So, okay, so now since we know this concept of using this operator, we can just change instead of our class and name it properly and say underscore rows underscore columns underscore calls. And then here I don't have to use this operator, just say underscore rows. It knows which one is from the class and which one is a parameter, underscore calls. Since now underscore calls as a value and underscore rows as a value, now I'm gonna use it. So I'm gonna say underscore rows there. And then after allocating that dimension, the outermost dimension, I'm gonna iterate through every single value or every single row within that dimension. R less than rows, R plus plus within that dimension, and then allocate for every single row. So I need to index first for that dimension in the specific position. And then I say is equals to a new IIoT sensor pointer. So after we've allocated the pointer, there's no need for you to place it there because now, as you can see, I've used it. I'm now using the square brackets because I've allocated for the pointer. So now I need to replace this pointer and allocate for it too. I replace it with what? Square brackets. And then I say underscore columns because those are the ones that I haven't specified yet. And remember that I'm getting default values for each sensor here. So I'm going to use those values. So I need to do another for loop. So int c, and then c is less than underscore calls c++. Then I'm going to say sensors row column is equals to, okay, yeah, I need to access dot the sensor ID dot int sensor ID. The sensor ID, remember what I said, is the current row times the current column, which is R times C. And then I use sensors again, RC dot dBl temperature is going to be the dBl temperature that I get from that sensor that I'm getting in as input. So it's going to be sensor. I don't know why it's not take. Okay, it's fine. So sensor dot dBl temperature. That's what I'm going to do there. Sensor dot dBl temperature. And then I'm going to have sensors, the next value dot int humidity is equals to sensor that I'm getting from the user dot int humidity. And then sensors row column dot what comes after this? The pressure, right? See, I just want to write it in that order. So there's the temperature, yeah, it's the pressure, then the intensity. dBl pressure is equals to sensor dot dBl pressure. Then sensors row column dot intensity is equals to sensor dot dBl intensity. So now I've given each sensor its default values. So there we go. That should be all. And it's still gonna have that warning about the return statement in the toString function. So now we're done implementing the parameterized constructor. So let's check. What about the default constructor? So basically what the default constructor does, it's going to redo this whole process. You see this whole process that I did here? So I would just copy and paste, right? Ideally, I would do that. Copy and paste in my default constructor. But then where I have int rows, I use default rows. Where I have int calls, I use default calls. And then here, I'm going to use default, default, default. So how do I do that? So the way you do that is you do constructor chaining. Instead of me having to explicitly type it, I'm going to implicitly say it. Basically indirectly doing it. So I'm going to say chain to this constructor. So take this constructor's implementation and paste it here. But for the different values, I'm going to provide my own values. What are those values? The first part is the rows, right? So I will use default rows. Okay, so let's do that. Let's create default rows. But wait, it's there. Yeah, let's use default rows. So default rows, then comma, default columns, and then comma. What's the next thing that I need to take in? As you can see, it's highlighting in blue. It's an IIoT sensor. And remember what I said. Remember how we do have a default sensor, so I don't have to worry about that. I already have a default sensor. I called it default sensor like this. But you can also do this. You can just copy this and then paste it here. Because that's in essence, that's what we're doing. But I've created variables for it so that it gives it meaning. I don't just write values there. Imagine if I just write like this. After 4 years, after I've coded this thing, after 4 years, and then I look at the code, I want to understand what's going on. But if I give it meaning like this and I say default sensor, I know, okay, it's just default sensors, default values for the sensor. So what this does, this constructor chaining, right? You're telling it, okay, go, this is where the chaining part happens, go to what? To this construct and copy and paste all of its implementation. But wherever you have int rows, use default rows. Wherever you have int columns, use default calls. Wherever you use sensor, use default sensor. So that's how it's going to implement that. Oh, by the way, I forgot. Let me see. You can do it. You can also do this. Let me see. You could also do it like this. Remember that at every single index, like at every single coordinate, because remember that we have a row and a column. Every single coordinate, we're getting back a sense. So you could do it like this. You could just say is equals to sensor, like this. That's perfectly fine. It's default values. I was just explicitly typing it, but there's really no need for you to do that. There's really no need for you to do that because remember what the two-dimensional array means. It means that at every single coordinate, since I have two values, I get back a what? An IIoT sensor. And what am I taking in the construct? An IIoT sensor. So I can just say is equals to that IIoT sensor. I just realized it now. I can just write it in short like that. So what this means, the third parameter, right, is the IoT sensor. What this means, it means that wherever you have this sensor, replace it with this. So it's going to copy paste this here and use default sensor. And then when it gets here, it's going to use default rows. That's exactly what constructor chaining does. So it's in essence, I'm implicitly or indirectly copying and pasting the same code, but I don't have to write that code. I just tell it to go there and take that implementation. That's what you're doing here. You're telling it go there and take that implementation and then replace the int rows with default rows and replace in columns with default calls and replace sensor with default sensor. That's what I did in this one line. That's how powerful it is, constructor chaining. So after this, I think we have to call the set sensor date. Remember that we need to, as the practical requirement, it says that this function must be called in the constructor that does the initialization. And remember, the set sensor date is just a void function. It has no parameters. So I can call it now, even though I haven't implemented it yet. So this is where we call that set sensor data function. And then I'm gonna implement the copy construct. So the copy constructor, I'm gonna give it initial values by what? Using constructor chaining again. And then now I'm just gonna use, I could use the same, let me see, I can use, yeah, I want to allocate for it, right? I could do that. I can do it many ways. I can use default rows and columns, or I can just do it like this. I can just say that object dot underscore rows. I can do it like this, but I'll just use default rows and default columns. Yeah, just to make things easier. Default calls, and then the last one is going to be default sensor, like this. And then now I've made sure that they are the same by allocating it. Yeah, I've just basically allocated memory for it, but wait, let me see. No, I can't use defaults because remember it needs to match with the same size as my class. So I'd rather use this approach. Let's do this approach. So obj monitor dot underscore rows. That's the safest way to go about doing it. Underscore rows monitor dot underscore calls. But then the default sensor doesn't really matter because at the end of the day, we're going to override that information and provide our own information. So now let's copy the object. So remember that this is a two-dimensional um, two-dimensional solution. So it works the two-dimensional array. So the best way for me to just copy the data is for me to just copy the two-dimensional array. So how do I do that? I do two for loops. The first one that goes through the rows. You can use the rows in the class, but I'm just gonna use the ones that I'm getting from the object itself. Dot underscore rows and row plus plus. And then for int c is equals to 0. And c is less than obj monitor dot underscore calls, and then c plus plus. And then now I'm going to say, now I need to copy this object, this obj monitors array into my own array. Remember what my array is called. It's called sensors. And then the specific coordinate row and column is equals to obj monitor dot sensors array. So that's, in essence, that's how I've made a copy. It's very simple. I've made the copy and I'm done. And then now I can move on to other implementations. So before we continue, let's implement the destructor. So the destructor, remember that we have rows and columns, right? So what I need to do is, okay, before we continue, I need to do this. I need to use the C asset library. So the asset library, right? It's basically the C asset library. Basically, you are setting values. So you're basically saying, make sure this is the case. So I'm going to do that. So asset what? An expression, and then it takes an expression, a Boolean expression, something that results to true and false. So let's check. What do I want to check? I want to assert that the object is not already null before allocating it. I don't want to deallocate something that's already deallocated. So how do I do that? I just say sensors, then make sure that's not equals to null, because I don't want to allocate something that's already allocated. I don't want to do that. So make sure that this object is not pointing to null. If it's not, then it means it's pointing to something, and therefore my intervention is required. I'm needed in order to deallocate memory for it. So I'm going to start by going through all the rows and columns, the rows, I mean, and then underscore rows, and then R++. Then I'm going to delete the columns dimension, this dimension. So how do I indicate that I'm going to delete it? I just write it in empty. I just write it the same way I'd write it, but I don't specify the column index. I just write it, leave it empty like this. It means that I'm emptying it out. I'm deleting it. But the syntax, the way it's done, you see, it's going to complain. The way the syntax work for deleting, you don't place it there anymore. You place it behind. You place it here. It still means the same thing, but just that it needs that syntax. And then after you fix that, that's done. You've deallocated the columns dimension for every single row. How do I know? Because I created a for loop for it. And then once I'm done, I'm going to delete the rows dimension now. Sensors, like this. Done. And then I'm going to make the sensors, remember that it's a pointer, so I'm going to make the sensors point to now. Once I'm done, and then boom, you're done. And then we need to implement the random number generator. So I need to go at the top and then implement it. So I'm going to have int generate random, gen random. Yeah, I think this is best. So it's going to have int lower, and int upper. I'm going to take in a lower bound and an upper bound. So let's implement that. So I'm just going to create a range, and range is equals to int upper minus int lower. And then I'm going to return, because the random function, it just generates a random value, I think between 0 and 1. Yeah, I think so. I think it's between 0 and 1. So I need to tell it to generate a random number between a specific range. So I call the rand function for generating a random value, and then I use the modulus operator and say generate for this range, right? And then I add the starting point, which is my int lower. So a plus int lower, that means it's going to start at int lower. So at exactly int lower. And then that's add, you're done with the random generator. So now let's generate random values. And remember, they said that is for each sensor. Generates data for each of the IoT sensor. And remember what I said, the IoT sensor is a two-dimensional array, right? And each sensor is allocated at a specific row and a column because it's two-dimensional. So let's do two for loops for that. So int r is equals to 0, r is less than underscore rows, r plus plus. And then I'm gonna do this for int c is equals to 0, c is less than underscore calls, c plus plus. And then now let's generate the random values, right? So I'm gonna say sensors, right? That specific coordinate, row and column. Okay, I'll change that later. So dot int. Okay, I need the sensor ID, and the sensor ID it's a row and a column, right? So what I'm going to do for each, right? Using the range of valid values. Okay, also using the range. So for that one, that's remember the sensor ID is just the row and the times the column. So that I'm just gonna leave it as is, just the row times the column, like that. It's not random, this one. There's no range for it, basically. So for the other ones, though, I'm gonna say sensors like this. All right, and then I'm gonna call the next one .dbo temperature. It's going to be equals to gen random between what range, right? So between 0 and 0 and 50, right? 0 and 50. Yeah, 0 and 50. So 0 and 50. Remember that dBl temperature is a double, so I need to cast it to a double. Remember the gen random function returns an integer. I need to cast it to a double. Then the next thing is I'm gonna do the humidity and then gen random between 0 and 40. It's an integer, that one. I don't have to cast it. And then pressure, and then the other ones are doubles. Sensors are c dot dBl pressure. I need to cast it to a double, so double. Then gen random, it's between 0.0 to 40.0. It's a double, and then sensors rc dot dBl intensity, which is also a double, and then the range is from 0.0 to 200,000 to 100,000 dot 0. Oh, okay, I don't have to specify the doubles. Remember that it takes an integer as the parameters. I just cast it at the end. I still get back an integer, but I cast it to a double. So I'm just gonna do that there. And then that's it. Cast it to a double. Then I'm done generating the random values. That's all I need to do there. Then now I need to implement my toString function. Let's see the toString. So the toString, the way it works is it works in terms of a malfunctioning or a faulty sensor. So let's see. And they said we should use a string stream to append the data. So let me use a string stream. So string stream, string stream ss, like that, right? And then at the end, I need to return a string ss dot. I use the str function, which converts the string stream or a stream of strings into a string. So I need to do that because this function gets back a string, not a stream of strings, just only one string, not a collection. Remember the term stream just means a collection, just like a river stream, just a stream of strings. So faulty, oh, blah, blah, blah. So let's do the faulty thing. So what is a faulty temperature? If it's less than or equals to 0, or value is greater than 40, that's a faulty. Okay, so let's do that. And this is, we're checking for every sensor, right? Yeah, we're checking for every single sensor. So since I'm checking for every single sensor, I need to do 2 for loops again. So int r and then underscore rows, r plus plus. And then for int c is equals to 0, c is less than underscore calls, c plus plus. And then that's it. So now I need to create variables to store this. So I'm going to call it, it's going to be a Boolean, right? Because it's a condition. Is temp mal. Basically, is temperature malfunctioning. It's an abbreviation because I don't want it to be very long. I don't want to have long variable names. So how do I know if temperature is malfunctioning? The temperature sensor. If that sensor is malfunctioning, if it's less than or equals to 0, so I'm gonna say sensors rc dot dbl temperature, right, is less than or equals to 0, or that's what they said here. They used or. They used or, not and. It's or the value is greater than 40. So I'm gonna say or sensors or dot is greater than 40. And then I think it shouldn't complain. Let me see. Okay, yeah, it shouldn't complain. Yes, because I just want it to be readable. I don't want it to be very long to end up going that side. So now I'm just gonna copy this and do it 4 more times. Before you copy, make sure you know what you're doing. Don't just copy paste if you don't know what you're doing. Else you're gonna have issues. So it's 4 of them, right? So the second one that I'm going to have to check is the humidity. And is mal. So is humidity malfunctioning? And then that int humidity, and then change this to int humidity. I say if it's less than or equals to 0, but greater than 30. Yeah, greater than 30. So change this to 30. And then the other one, they're saying if the pressure is less than or equals to 0. So I'm going to change this to int press for pressure is press mol. And then dBl pressure, dBl pressure. If it's less than or equals to 0 or greater than 30.2, right? Then light intensity is less than 0. Said less than, not less than or equals to, just less than. Or it's greater than 1,000, than 10,000, than 100,000, I think, not 10,000. But is it 100,000 or 10? Yeah, it's 100,000. So this is the light intensity. So I'm gonna say is light mal. So it's the light malfunctioning. dBl light intensity. Yeah, so it's dBl intensity. dBl intensity. I have everything now. So they're saying if more than one sensor in the IoT is malfunctioning. So I should output if more than one is malfunctioning. How do I know if more than one is malfunctioning? Basically, what I can do is I can create a counter variable. I can do this int, and then I'm going to call it int count, starts at 0, right? And then I'm going to check every time I have a malfunctioning sensor, I'm going to add 1. And then I check that value. If that value happens to be greater than 1, that means I have more than one sensor that's malfunctioning. excuse me, I have more than one sensor that's malfunctioning. So I'm gonna do that, int count plus plus, and then if is if the humidity is malfunctioning, that means I need to count it as one of the malfunctioning. And then if is press is malfunctioning, and say int count plus plus, and then if is light malfunctioning, I need to say int count plus plus. And then now I need to check the value of int count. If the value of int count happens to be greater than 1, that means there's more than one sensor that is malfunctioning. Because remember this if statements, I was checking, is this one malfunctioning? And then I count it. I say plus 1. That means 1. That means that one is malfunctioning. And then I check, is the humidity malfunctioning? And then I add a 1. That's going to become 2. If it isn't malfunctioning, it's going to skip. So yeah, it's going to check. And then if it's more than 1, it should output M, right? So I'm going to use string. Remember the string, it operates like the cout, but then now you're just adding it to that object and then returning, you can convert it to one string, just a string. But yeah, that's in essence, it works the same way as a cout. So I'm going to say output M with the space like that. Because if you check the desired output, there's spaces in between. Let me see. Okay, it actually starts at the end. So there's a space after. So after you display the character, there's a space. So the space is only after. So it's just after here, after displaying. Then they're separated by spaces. So I just need to do it like that. And then now let's look for another condition. The toString function should return the following characters. Okay, it should output a T if only the temperature is the one that's malfunctioning. How do I know if it's the only one that's malfunctioning? So I'm going to use an else if. I'm going to use else if statement because only one can be true at a time. So that's why I'm using an else if statement. So else if is temp malfunctioning. So that means that one is malfunctioning. And is malfunctioning. I can't say it is malfunctioning. I should say is not malfunctioning. Because remember, I'm checking for the condition whereby only the temperature is the one that's malfunctioning. And then if it's not malfunctioning, and then I'm going to have an and again. Yeah, okay. Let me have it there. Have and is, let me see, is press malfunctioning. And then I negate it. Remember logic. I negate it as the not operator. That means it's not malfunctioning. And then is light malfunctioning? No, is not. Because remember, I only want this one to be malfunctioning. The rest should not be malfunctioning. That's why I'm using the not operate. And then what should happen? So what should happen is that it should output a T. Remember that there needs to be a space after. There needs to be a space after. There needs to be a space there. So output a T, and then I need to repeat this 4 times. Yeah, because I need to output for each sensor. So if I should output H if only the humidity sensor is the one that's malfunctioning. So I'm going to change this to an H and then change this to a not, and then remove the not and because I want to be the one that's malfunctioning, but the rest are not malfunctioning. And then P if only the pressure is malfunctioning. Okay, H. Okay, so P if the pressure is the only one that's malfunctioning. So I should remove the not character on press is press mal because I want it to be the one that's malfunctioning, right? And then the rest shouldn't be malfunctioning. They should not be malfunctioning. And then the last one is L, if the light intensity is the one that's malfunctioning. Where's it's L, if the light is the one that's malfunctioning. So I remove the not, I remove the negation. And then else, there's also a condition for when none of the conditions are true. None of the conditions is true, so I output a dot. So I'm going to output a dot followed by a space, semicolon. And then remember that I need it to be in a grid form. So once I'm done with that specific row, I start on a new line. So I'm going to exit the row for loop. So I click this curly braces there so that I can see where it ends. I scroll down, this is where it ends. So after this row, I output an end of line character like this. Then I'm done. That's literally all I have to do for this practical. And then now let me create an instance of my class. So I'm going to say IIoT monitor. The way we would create a variable for the structure is the same way. Obj monitor. I'm going to use the default constructor. So I'm just going to leave it like this. I won't pass in any parameters. And then I'm just going to use the cout and call the string function dot to string to display the result. And then I just build and run. There we go. There's our output. It's outputting exactly as it should. As you can see on at the beginning, there's no space there, just like the way they wanted us to output it. If you check here at the beginning, there's no space. There isn't any space on the left-hand side. So this is perfect, 100% perfect. So yeah, that's it for Preg 2's memo. I'm gonna make another recording for Preg 3 and then Preg 4.